So we got a bunch of rain, so I can't really do this in the field. So I have the planter tricked into thinking that it's planting up in the air while I drive around this parking lot. So first things first, compared to people that saw this product last year, there's a couple of changes. First of all, we've added 3 different ways you can work with the system. There's the system overview page, the row unit detail view, and the mapping view, and then a bunch of other setup stuff that I won't get into right now. The system overview screen is the byproduct of a response to customers saying that they just want a simple overview, especially for some operators that aren't super tech centric. They just want a simple overview that at a glance can give them a picture of the entire planter. So what this screen has is you can control all of your planter settings, but it gives you an overview of all the different parameters, and it will alarm and tell you if a setting is outside of a nominal condition and if there's a problem that you need to deal with. And then on this screen, what it does is it averages values across the whole planter. Change from last year is that we're now directly reading the supply pressure from the tractor on the interface. It will alarm if it drops below 2,500 psi. You're directly reading the uplift pressure on the user interface, and so it will alarm at you if you drop it below, say, 500 psi. You have the average cylinder pressure, which is the actual pressure inside of the cylinder. You have the average gauge wheel load across all the rows. This is the actual sensed force on the gauge wheels. You have the true downforce, right? So instead of just the applied pressure, because this system has uplift, this year you'll be looking at it'll be giving you the true downforce that factors in the uplift. So notice now that as I increase the uplift pressure, the true downforce can even be negative, so that the value that we're showing in terms of our actual downforce is registering in pounds, and it factors in the uplift pressure when we do that. Okay, you've got your average seed depth if you have the active depth control system. You have the average closing wheel depth if you have the active closing wheel system. It tells you what the closing wheel cylinder pressure is, and it tells you what the actual closing wheel force is in pounds. So we're going to be registering that in pounds. And last but not least, you've got the furrow compaction sensor, so it's reading the furrow compaction sensor too. Now, if we go over to the row unit detail screen, this screen, I only have 1 row on this planter. So it looks like this. This is the screen that people would have seen before, where it's going to give you a bar graph output of all of these different datas. Now, if you have multiple rows, obviously you'll have multiple bar graphs for each row. Scroll down, you've got each data layer presented in a bar graph form. Okay, so some people might prefer to look at the user interface in that sense. And last but not least, you will be able to go to a mapping interface. Okay, so where you're mapping the true downforce, and then here you can select any different data layer, which is here. Notice that because the blue represents a negative gauge wheel load, a total loss of ground contact, at 0, if you're at 0, it reads blue, but if it's above 0, it reads green. So because it's up in the air, it's just kind of toggling around between 0 and 3 or 4 pounds of just basically noise in the system. You've got your seed depth, which I was kind of messing around with a little bit here. It doesn't work exactly correctly when you're up in the air, but now keep in mind with the seed depth, what we're registering here is actually the error in the system. So if the target seed depth is set at 1.7, it's going to be mapping how far away you are from the target, not just the setting itself. It'll be the actual amount of error in the system there. You've got the closing wheel depth, which again, the closing wheel depth, like the seed depth, is mapping the actual error in the actual value relative to the target value that you've input for your closing wheel depth. Okay, And then you'll also have a map of the closing wheel downforce, which is the pounds of downforce pressure on the closing wheels that you'll apply. Notice that we have color ranges between 0 and 127 pounds of closing wheel force with the active closing wheel system. And you can go to the furrow compaction map, which will is in prototype stages and needs a little bit more work, but it's basically giving you a real-time map of the compaction of the furrow. Okay, so that's the mapping interface. And then you can go over to the row unit screen, where you can basically do some fault overrides, where you can enable all or disable all. If you have a problem with your lift switch, you can set them into manual mode, and you can set a manual mode for the entire system. That would be something you would do, for instance, if you had a sensor failure or something like that. You've got a task management system where you're basically loading a particular field task. You've got a field management system. We're going to be bringing out some pretty cool products in terms of how you can automatically detect your field boundaries and get them into the system. You've got some presets here. Now this is what's really cool. So if you want to quickly switch back and forth between settings, let's create a preset. Let's call it corn. Okay. In corn, I'll say I want my gauge wheel load to be 150 pounds. I want my seed depth to be 2.25. I want my closing wheel depth to be 1.25, and I'll save that. And so there's a preset. Okay, now what I'll do is go back over to System Overview, and notice that these presets are enabled right here, so that when I click on one of these presets, it will automatically move to those settings with the touch of one button. Diagnostics, there's going to be some stuff coming there. And in settings is where you set up your implement. You've got some version stuff. You can switch into night mode. You can change the kind of softening of the averaging of the data stream. You've got some GPS settings there. We can use either a standard puck antenna, or you can actually use a more precise CAN-based RTK antenna with it. You've got some things that tell you about the amount of data storage capacity internal on the telemetry controller, right? Because this, of course, is a completely Wi-Fi based system, and it's going to be only used on iOS for the next year. And as you can see, there is no cable connection, so you can walk back to the planter and you can work with this system, and you're not tethered to a wire, and you don't need to provide any type of CAN bus connection from the planter up to the cab of the tractor. So that culminates the review of the updates to the FurrowTechnik control system. Thank you.